Okay, students, this is your well-rounded math teacher. This is Mr. Bakar. We're going to work on section 3.5, last section before the test, solving systems with three variables. Okay, this is a typical three-variable problem. We're just going to set this one up. We're not going to solve it, just so you can see where we're coming from. Anyway, at the 2004 Summer Olympics in Athens, Greece, the United States won 103 medals altogether. They won 6 more gold medals than bronze medals and 10 more silver medals than bronze medals. Write a system of 3 linear equations that could be used to determine how many of each type of medal the U.S. won. Let G represent the number of gold medals, S represent the number of silver medals, and B represent the number of bronze medals. Pretty obvious and straightforward stuff. Well, the first equation is going to come right from here. 103 medals altogether, so it's real simple. Gold plus silver plus bronze, if you add up all those medals, it equals 103. Now, we're talking about three variable systems, so we need three equations. If you have two variables, you need two equations in order to solve for both variables. If you have three different variables, and we do G, S, and B, we need three equations. The other equation is going to come from this. They won 6 more gold medals than bronze medals. So I guess you could say gold equals bronze plus 6. They won 6 more gold medals than bronze medals. So this would be an equal equation. And what's the other one? And 10 more silver medals than bronze. 10 more silver medals than bronze. So I'd say silver equals bronze plus 10. There are three equations, and we need three equations in order to solve for 1, 2, 3 different variables here. And this isn't too bad. We'll get into that in a little bit. Here's a typical 3 by 3. It's called 3 by 3 system. And the thing of it is if you want to solve this for x, y, and z, so now you're going to have an ordered triple, x, y, and z. And we're looking for x, y, and z right here. You need three equations, and we do have that. And what you have to do is break a 3 by 3 down to a 2 by 2. 2 by 2 is what you're used to working with systems, an x and a y and an x and a y, and then solving them using substitution or elimination. Well, we have to take this thing right here, okay? And you can see it's three equations, 1, 2, 3, and then the three variables are x, y, and z over here. And break this down to a 2 by 2. And the way you do that, it says hint over here. Here are three hints. We're going to use elimination, elimination, elimination. Yeah, it's basically elimination. Let's get rid of this. Okay. So what we want to do is look at the two equations here. Now I see this. You either want to eliminate, add two equations together, like these two equations, and either eliminate the x's, the y's, or the z's. Then take the third equation and add it either to the first one or the second one, and eliminate the same thing, the x's, the y's, or the z's, to create a 2 by 2 system with just two variables. And I'm just going to do this. First thing I'm going to do is, well, this is 2x right here. I'm going to multiply this top equation by -2. If I do that, I can eliminate the x's. Now my new equation for this top equation is going to become -2x minus 4y minus 2z equals -20. I'm going to bring down that second equation now right here. 2x minus y plus 3z equals -5. Now the biggest thing is making mistakes. I might have made one already. I don't know. We'll see. But when I add these two together, of course, my x's cancel out. -5y plus z equals -25. And then I'm just going to move this right over here. Oh, we'll leave it here for right now. Now, what I'm going to do is I'm going to take this third equation, and it doesn't matter which one of these two I add with it or add to it. I need to eliminate the x's again though, because my new system that I'm going to create, this 2 by 2, has a y and a z. So we got to eliminate the x's. Now if you look at this, this is 2x and this is 2x. I could basically just take this second equation, multiply it by -1, and add it to the third equation here, and eliminate the x's. Then I wouldn't, and the main thing is you can't use the same two equations you did the first time. So multiplying this -1 through the second equation, I get -2x plus y minus 3z equals 5. Bringing down this third equation now, 2x minus 3y minus 5z equals 27. Adding them together, well, of course, the x's eliminate each other, and that's what you want. -2y minus 8z equals 32. And now we're going to take this 2 by 2 and this 2 by 2. Now I have a system that is 2 by 2. Two variables, two equations. Now I can solve for y and z. And this is how we go from a 3 by 3 down to a 2 by 2. That's the main thing. And now I'm just going to solve this bad boy. And I think I will eliminate the z's by multiplying. Let's go. I'm going to multiply the top one here by 8. If I do that, I'll get 8z and -8z. So -40y plus 8z equals -200. And then we got the -2y minus 8z equals 32. So this adds up to -42y equals -168. Divide both sides by -42. And you get y equals 4. So there's my first solution. Now I can find z, because I'm going to take y and plug it in right here and solve for z. So -2 times 4 minus 8z equals 32. -8 minus 8z equals 32. Adding 8 to both sides, -8z equals 40. Divide both sides by -8, and we get z is equal to, what do we got, -5? Yep, okay. So now we're going to go up here. Y is 4, and z is -5. How do we find x? Well, we'll plug in, we'll go to the first equation. Plug in the y we have now and plug in the z we have now. I'll do that right here. X plus 2 times 4 plus the -5 equals 10. So x, this is going to be 8 minus 5. 8 minus 5 is 3 equals 10. Subtract 3 from both sides, and I get x equals 7. And there it is. Now, what you should do is this. If this was too fast for you, didn't understand it, definitely hit rewind, go back and look at it again. Kind of try and piece it together a little bit. I'm going to let you guys try this one. And you might get it wrong or you might get it right. I really don't know. But here's the deal. If it doesn't work one way, try it a different way. You just got to remember that you got to break it down to a 2 by 2 by eliminating either the x's, the y's, or the z's. Break it down from a 3 by 3, 3 equations, 3 variables, down to a 2 by 2. So when you do start eliminating variables, make sure you eliminate the same one. Like you eliminate the y's when you add 2 equations together, and when you add the other 2 equations together, eliminate the y's there also. So you try this one, and you know what? If you make one little mistake, it's going to screw up. So just try it again. start over from scratch. We're going to go to the word problems now. And we're going to try setting this one up. The sum of three numbers is 20. Well, I'm going to say my first number is x, my second number is y, and my third number is z. So the sum of three numbers is basically this: x plus y plus z equals 20. The second number is 4 times, question here is this, is the second number is y, so I'll say y is 4 times the first number, so that's 4x. So y equals 4x. And here's the other equation now. The sum of the first and third is 8. Sum of the first and third. So the first number is x, third number is z, and that equals 8. Now, there's a few different ways to solve this one because it's not 3 variables in each equation. You want to break it down to a 2 by 2. If I look at this right here, x plus z equals 8, that's kind of nice. It's already a 2 by 2. This one right here is a 2 by 2 also. I could subtract 4x from both sides and say negative 4x plus y equals 0. But basically what I'm trying to say is this. If I could eliminate this y and just have my z or x and z here, I could work with this x and z over here then. And I notice this, y is equal to 4x. So I'm going to use a little substitution for a minute here. When I do that, that top equation becomes x plus 4x. I'm plugging that in right here for the y, plus z equals 20. Now x plus 4x is 5x, plus z equals 20. So I have 5x plus z equals 20. So I went from a 3 by 3 right here and here and here down to a 2 by 2, and that's what you want. Hey, I think this one's going to be easy to solve. All I got to do is make one of my z's negative, and I think I'll just run a negative through the top here, basically multiplying everything by -1, and end up with 4x. The z's here cancel out, equals 12. And you know what? Dividing both sides by 4, x equals 3. So my solution over here, 3 is the first thing I find. Now I'm going to go back to the original equation, or actually let's just go to this one. I'm going to plug 3 in for this x in the second equation. Let's look at it right here. 5 times 3 for the x plus z equals 20. So 15 plus z equals 20. Well, if I subtract 15 from both sides, I'm going to get z equals 5. Only thing I have left to find now is the y. I'm going to go to my original first equation here, x plus y plus z equals 20, and start plugging things in. So 3 for the x, plus y is what I'm looking for, plus 5 equals 20. So y plus 8 equals 20. Subtract 8 from both sides, and I'm going to get y equals 12. So my 3 numbers are 3, 12, and 5. And that's how you do a word problem. Now we're going to do a bunch of this stuff tomorrow, but this was a good start. So you guys try that number 1B. If it doesn't work out, just quit. Go make a sandwich or something, or relax, watch a little bit of TV. Erase the whole thing, start over from scratch, and try and eliminate a different variable. You're probably making the same little mistake over and over again. So don't get stressed out about this stuff. I just helped my daughter with this stuff, and she kept telling me, I'm so stupid, I don't get math. But really, she was doing exactly everything right. She's just making one little mistake with her negative. So don't get frustrated by this stuff. Just start over from scratch and try it again. Okay? Peace out. See you guys tomorrow.